Hi, good evening. Today we are going to explore zonal architecture further. Right. Before exploring zonal architecture in detail, let us compare the difference between the domain architecture and then the zonal architecture. What is domain architecture? In domain architecture, we have the controller for domain. For ADAS, we have a controller. For body domain, we have a controller. For infotainment, we have a controller. These controllers are connected with number of sensors, right? They are connected with different cameras and then different sensors, something like that, right? Those are input to these domain controller, right? Depends on the domain. The number of sensors, input sensor are connected to this domain controller. The domain controller will transfer or will communicate to a central vehicle compute unit, again, which is a high speed computer. So that get inputs from these controllers in terms of data, right? Then it activate respective actuators, respective control units for the system, right? That is what a domain controller. To define the domain controller in simple term, so there we have domain architecture in simple term. There we have controllers for each domain. Each domain will have their own controller. They are connected with, those controllers are connected with the domain specific sensor, right? So for that particular domain, what are the sensors needed? Those are connected, right? Those the controllers digitize and sense those inputs, and then they are transmitted to central vehicle compute unit, which is a high speed computer, right? This high speed computer, which in turn connected with different like actuator, connectivity unit, and other stuff to perform the action right now. So the problem with, or a limitation with, this domain architecture is tight coupling, as we spoke before, right? Sensor and actuator depends on the central compute, right? So these sensors and actuator always require some sort of input from the central vehicle compute, which is giving the commands, necessary command to them. Then synchronized update cycle. So when you want to update hardware and software, you have to update both. So here there is no like you can update the software and hardware in a different time frame. That's not possible because the domain controllers are associated with domain sensors and then respect to domain software right now. So you have to update both. Then here, as we have each controller for each domain, number of cabling and the number of ECUs in the network will be more, which increase the size of the system, right? When you have a complex network, your validating effort will be more. So you have to spend more time to test, more time to validate the system right now. That's how it works. Okay, what we have in a zonal architecture, as we discussed before, zonal architecture as zone controller. Each zone will have their own controller right now. Those zone controllers in turn connected with number of sensor associated in that zone, sensors and actuator connected in that zone. The zone controllers are, so the sensor or actuators that we have in the zone are not depends on the central vehicle compute unit. They are independent. So they are direct, the immediate contact is zone controller. From zone controller, we get the information to the central vehicle compute unit via a high speed link, probably via automotive Ethernet with different speed, CAN XL, like that. We have many, right? Using those, we get the input, right? So that is the main difference between these two. As we divide the car into different zone and connect the sensors and actuator in that zone, we get the independence, sensors and actuators independent from central compute, decoupled update cycles. You can update software and hardware in a different time frame, and then fewer ECU and shorter cables. Right now, here as the number of controllers in the vehicle is reduced, we have a very very lightweight network and the limited cables. Right now, simplified validation. As the network is simplified, the validation of effort also minimized. Understood. So it is in that way. The key benefits in the zonal architecture is independence. Sensors and actuators are independent from central compute code, different update cycles. You can update your hardware in a different cycle and your software in a different time frame. So they are decoupled. You can work independently with them. Right now, longer design life. So you can take long time to design because there is no pressure to bring software and hardware together. So you can take a long time to design your hardware or software. Reduced ECU and cable length, that is we already discussed. And then simplified architecture and validation. So these are the key benefits that we get when we go for zonal architecture. Right now. So not only that, in zone architecture, we get a more control, more flexibility, and more efficiency, enabling advanced software, optimized power, and future-ready vehicle. These are the some of the additional benefits that we have in the zonal architecture right now. Okay, how we get more control for OEM? How OEM get more control when we go for zonal architecture? Because these zone controller gets their software update and firmware update from over the air, right? Meaning they can connect with the cloud and can get their update. So the OEM can update their zonal control software as well as their firmware in the cloud. From there, they can get it via telematic link and can update right now. So they are always having these vehicles, zonal controller implemented vehicles are always connected with the cloud. So the OEM can analyze vehicle performance and then he can study the vehicle. The vehicle is in complete under what do you say under the monitoring of OEM right now. So they can track the vehicle and its performance. So service-based software architecture, as I discussed on the first day, here it is not a signal-based architecture. Here for every signals and every parameter that required for the system is converted into service right now. So so that we can call the service in any applications and can get that value, that is signal value right now. So that is the these points highlight that the OEM has more control over these vehicle right now. Then optimized power distribution right now. How optimized power distribution is achieved? Here they use something called zone-based power topology. Right now, power distributed to zone instead of many ECUs in reducing wiring losses and weight right now. So in case of your domain architecture, there each individual zone will get or every ECU will get the power. Right here it is not like that. The power is distributed from the centralized power distribution model to zone controller which in turn distribute the power to sensor, actuator, whatever that is connected with that particular zone controller. Right now it is in that way. Right. So it is also having the power management modules and sleep behavior. That means when the vehicle is not used or when the module is not used, in that time they can go for sleep right now by stopping all communication and other stuff that can increase the battery life of the vehicle. right now. So it's also increased the efficiency of the vehicle, improved energy efficiency, extended vehicle range, lower thermal load. These were the advantages that we have in the zonal architecture with respect to power optimization. Okay, now. So in total, summing up all the point, right? What are the benefits of this zonal architecture? We get a continuous improvement via OTA, FOTA, meaning firmware over the air and cloud, flexible service-based software architecture. I believe these were, we discussed them in the first day. We simply recapping all of them one more time. Real-time performance closer to the edge and reduced complexity, weight and cost, optimized energy use, ideal for like battery enabled vehicle and then hybrid vehicle right now. So more reliable, scalable and future ready vehicle. That means you can update the software of this vehicle over a period of time, right? As I told you before, we have a foundational hardware and then the software is like the development of software will happen over a period of time right now without bothering about the model layer so that we can improve the vehicle performance. Okay, team, that's all for today. I want to end today's session with this. Let us discuss more detail in upcoming session. Thank you. Thank you for watching.